Hey, do you like multiplication?
Maybe. Is that okay?
Yeah, it's cool. I like math.
Cool.
Let's go ahead and move now to 8.41. All right, a probability distribution, and a distribution is just a fancy word for a graph. A graph is a mapping of each outcome of a statistical experiment to its probability occurrence. Okay, so I have two graphs down here, and I want to define a couple of things out here. Okay, this one on the left side, this one is called a discrete, let's make that thicker, discrete random variable. That's this graph here in blue. And basically, some key things is that it's finite. You know, Thanos wanted to find the infinity stones because infinity means he lasts forever. Well, this is finite, so that's the opposite of that. So human beings are finite. We're only going to live up to maybe 100 years old. Here's another one. It can be counted. It can be counted. Okay, so another thing is that it's graphed. What do you notice? Are they touching or not touching? They're not touching. So the graph has space. Between them, because you can't have an in between. You basically, if you think about it, you couldn't roll a sum of 7.2. Okay. All right, let's try another one. Let's try this one. Do you guys know what the other one's called? Yeah, that one over there is called a continuous random variable. Continuous random variable. And what are some characteristics of this one? It could be any value. Like I got a new used car and I'm trying to keep my miles per gallon. So it's this one. It's kind of messy. This purple one over here. And I'm trying to keep my miles per gallon like over, 18. So right now I'm getting like 18.9 miles per gallon. Does that make sense? The sum on the blue side was, a whole number. And this one can take any value, decimals or fractions. Okay, what do you notice about our graph? Our graph is basically a histograms. Which is basically area under a curve. That's it. Under the curve. And over here, we basically had bar graphs. Okay? All right, so we have these things called outcomes. And an outcome is just the result. What happens? When I roll the two dice, the results are individual ones. It could be like a sum of 12, or maybe like 23.9 miles per gallon. Then we have something called a sample space. What is a sample space? All outcomes. You kind of know, all the samples that can happen when you roll 2 dice can either you add them up, it could be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe your car is like going, you don't really accelerate, you have optimal conditions, and you can go all of the miles per gallon my car can get. And the last one, what color have we not used? Let's use orange. Is, well, big one, probability. And probability is just the likelihood of an event. So for example, the probability of rolling a 12 is 1 out of 36. Maybe the probability of the time I'm driving my car and I want to get 24 miles per gallon, maybe it's pretty low. Maybe I'm getting like 15. Alright, let's move on to key concept. Conditions for probability distributions. The probability distribution of a random variable x. So again, the x can refer to the sum of 2 dice. It could be miles per gallon on my Honda Pilot. It must satisfy these conditions. The probability of each value of the random variable must be between, well, think about like rain. The probability it rains is between 0 and 100%. Or 0 and 1.0 as a number. And the sum of the probabilities of all the values of x must equal also 1 when you add them all up. Okay, let's think about this. Let's do these examples over here. Example number 1. Classify each variable as a discrete or a continuous. I have the number of songs on random selection of smartphones. Okay, so question, can I count, look above, discrete is where we can count, let's do that color coded. You can count, that's a number, or purple, this could be any value. Those are from our notes above, right? So you can count the number of songs, right? The number of songs on a random selection of a smartphone is discrete because the number of songs is countable. Alright, let's go ahead and try the second one. The air pressure in a random selection of basketballs. Well, let's just say I go up to a basketball and it measures, I don't know, 7.5. Or it can be 8.2. It can be 9.9 pounds per square inch. Therefore, air pressure is continuous because it can take any value within a certain range. So there's a bunch of range of numbers. Go ahead and try questions C, D, E, and F, and then we'll go over theirs together. Alright, if you're a swimmer, you're measuring your time, so the times, someone can be going fast, someone can go slow, just like the Olympics we just saw, so continuous. The number of students in class, well, although they can take any value, I'm actually counting them, so that would be discrete. Individual archery scores, same thing. I don't know what the numbers are. They score 5,000, maybe 5,002. You can count them, so that is discrete. And the amount of water in a bottle, you might think, well, they all have the same 16.9 ounces, but that's not true if you actually measured all of them. So this one would be continuous because there is a range that which we would find. Okay, go ahead and do questions 1, 2, and 3 as our practice, and then go ahead and press play when you want to see the answers. All right, let's go over question number 1. The number of texts received per week. Well, although there might be a range of numbers, you can count them. And they are whole numbers, right? You don't receive 2.4 text messages from your special someone. Question number 2, the number of likes for a web page. Can you count those? Yes, you can. That is discrete. And the height of a plant after a specific amount of time, well, they might have a different range of values. You might have 6 inches, 12.2 inches, 11.4, therefore that would be a continuous.
And math is all that is surrounding you. Math is so much more than 2 plus 2. You can understand it. Take that number and divide it. Math was made for me and you.